Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to Dr. Fauzi. My name is Nashita Mutiara Gandana, and today I'm going to present about my assignment on water pumping system. So I have already done the two steps before this to get to the simulation. The first one is to do the hardware configuration on the TIA portal, and secondly to create a ladder diagram. As you can see here, this is the ladder diagram that I created before, with each component being addressed to its specific name. For example, IO1 to tank low level switch, IO2 to tank high level switch, IO0 to pull low level switch, and finally the Q0 to the motor pump. As you can see here, we can I have picked the SR flip-flop instead of the RS flip-flop. The SR because we are going to prioritize the set input instead of the reset input. So SR is going to be utilized in this particular system. So once we build the network, we're going to try to simulate it onto the PLC sim. Okay, before this, we already created the sim table onto the PLC sim, and now we're going to try to simulate it on the condition that this particular water pumping system is working at its normal phase. So when the pool is full of water and therefore the pool low level switch is active and sending a true signal, which signifies that it is sending a certain amount of volt to the PLC. So the tank for the low level switch and the tank for the high level switch is both on. Tank low level and the tank for the high level is both on. So it is sending it, the pool is currently full of water, and that is why the pool low level switch is off. Okay. Now the tank is empty, and both the tank for the low level switch and the high level switch is active. So when the tank is empty, the pool low level switch is also true. The value is true. And therefore the pump is working to increase the level of the water within the tank. So, okay. So then the tank for the low level switch becomes active as it detects the water. It is important to remember that the flip-flop still remains in its set command despite the fact that the pump is still running. So for this one, the pool low level switch is switched on, and the tank for the low level switch is also switched on. So the tank for the high level switched off because the water is currently still pumping. So as soon as the level of the water reaches the high level switch and activates and it activates that, the reset input becomes activated and therefore the pump will stop working. So then the water level will decrease gradually due to its utilization to a designated outlet, and the high level switch will then be deactivated after a while. So before this and this were on the tank, and then the high level switch will switch off because it keeps on pumping. The pool keeps on pumping on the pool is being extracted, the water inside the pool is being extracted, so the high level switch will also switch off eventually. So when the water reaches off the below the low level switch of the tank, the switch also becomes inactive over time, and so the pump begins working and the water level starts to rise again. So the above process will be repeated unless the pool of the low level switch switches on, and that which causes the pump to stop working immediately even when the set input of the flip-flop is active due to the priority of the set input. So that is the simulation of how a normal water pump should work in a PLC diagram. And so the steps coming up to this is we have to first configure the hardware. Just a small recap. First configure the hardware of the system. And then while you're configuring the hardware, you can create your device and network by getting onto the hardware pane on the right and putting in the device at its correct order using the flip-flop that you want. And after that, for you to be able to use the PLC sim, you have to first simulate the diagram and also download any configuration, download the diagram. Okay, my favorite way to do it is to open, right click on the CPU that you have chosen, and you have to download to device the information. So in order for that, you are able to connect to the PLC. Here, it is always written here in the general account. So that is all I have for the first part of the assignment. Thank you very much, and thank you very much for your cooperation, and have a nice day.